So from a building point of view, the house originally started, obviously there was an existing house here, as you can see, well, as you may have noticed, walked up on the left-hand side, over that side is actually red zone. So there were houses up there. This house wasn't red zoned so much as, unfortunately, the elderly lady that had it had battles with the insurance company. So unfortunately she passed away, but then the clients then purchased it, which we demolished, and the footprint is, I won't say the same, but very similar in that where the garage is and the lower apartment, which you'll see. So basically, through the design, they wanted to maintain, obviously, the views out as far as the mountains and out to the Kaikoras and things like that. But what was very important to them was the performance. And like some of you guys, if you're thinking about building, it usually starts from a tour. So these clients were on a tour a couple of years ago. I can't remember which one they were on, but I think they had a look at the Kirkwood Superhome. Some of you guys have seen that, the Riccarton, the big cottage. So they had a look at that one, and then obviously it evolved from there. So through the design process, we were involved in coming up with the details or helping provide the construction details for it. As always, we follow our base better best guide for superhomes. There's obviously different rating tools around the place, you know, for Passive House or Home Star and stuff like that. But the Superhome design guide is very straightforward, so it's based on experience. Obviously you have your base better best. This one falls into the best category. We have a set standard of how we like to build. Obviously building code, we all know, if you're here, you know why we're here, why the Superhomes movements are around, right? So I drew a line in the sand many, many years ago after learning about how things should be done and how the old code performs. So, for example, a house I built many years ago before I knew what I knew, the client asked us to have a quick run through the house and get it up to, and just do it a tidy up to get it ready for sale. And obviously it was a brick house, double glazing, aluminium, so just your standard building code house. And of course all the rooms on the south side where the bath, the curtains all had some mould on the back of it. So in order for us to sell that home, that we put in a balanced ventilation system with heat recovery. So that was, again, that line in the sand that is very, very important to us. So starting from the ground up, obviously we've got a insulated foundation. It's broke because this is the way it's been designed with the engineering. It's not a standard rib raft where you've got insulation underneath and then insulation up the side. It has in portions, but because we were embedded quite deep into the rock, we had to have a lot of engineered beams and stuff. So basically down below, it has a topping slab. So the foundation is structural. It is in direct contact with the ground, but the topping slab, which holds the underfloor heating, is fully isolated from the rest of it. So that's insulation underneath and up the side. So that was poured after the walls were installed and stuff like that. The floor you're standing on here, in a normal two-storied house, most people would put a timber floor in, but we went with a suspended concrete slab so we could then house the upper level underfloor heating, hydronic underfloor heating. So encompassing with that, we obviously, building up from the walls, we have, the floor, we have our high performance walls. So down below, again, because of the hill site, and we've gone into the existing ground level, we've got masonry block walls for the structure. So on the back in the day when you had the old block garages and people decided to put those into living spaces, what used to happen is people would batten and then insulate and line from the inside. But obviously, if you know anything about dew points and where the moisture vapor turns into moisture and you get mold, that's going to be on the inside of the wall. So obviously, insulating around the outside is the most important thing, which is what we've done here with an XPS all around, and then we've built up our layers from our ultraclad or our stone or our cedar. So again, it comes down to those layers. The upper level is all timber frame, so that is using eco-panel walls, basically, which is built up of structural cavity battens on the outside, which means we can span the studs with no dwangs, having full insulation, and then building up our layers with our airtight layer on the inside with our service cavity. I forgot to bring my sample wall, but most of you guys will probably understand what that wall build-up looks like anyway. Windows are European windows from Kaufman, which maybe is downstairs. But yeah, if you want to get some, there's obviously some paraphernalia over here you can grab as you get some information. So they're European, triple glazed. On average, they are about R value of 1.2 versus the 0.5, which is in the code at the moment. So if you notice, sorry, I'll just get behind here. Well, the great thing about these windows is the triple glazing is not only the performance of the thermal, but the acoustics. Oop, it was already open. So you get the road noise from the causeway. So the good thing about those is they're very, very acoustically sealed as well.
Very cool.
So you just, when you're on a high traffic area, it's amazing. So with the air tightness layers, we always aim to make it as airtight as possible. So it's got in a ProClimber airtight layers, which we got a 0.56 blower door test result, which is below passive house standards, what they strive for at 0.6. From there we have a warm roof, which is built up of mass timber, so CLT. I think it's about 166, was it Freddie? So 166 mils of solid timber, cross-laminated, which you can somewhat see where the joins are, but they're about 2.4 wide, so we had to crane them in from the driveway, and obviously getting them up here was quite problematic. So there we've craned those on, and on top of there has been a build-up of PIR and EPS polystyrene to create the insulation up on top, and then from there it's got Sealco, which is a membrane, a TPO membrane on top of that. So the EPS and the PIR were actually shaped off-site, so they form what you'd consider a standard roof, like a valleys and hips and stuff like that, no gables of course, but allows the water to run off. On top of there we have our solar, which is a 14 kilowatt system, providing power to the batteries at 14 kilowatts as well. So that's going to help keep energy costs quite low. There's also a electric car charging point as well.
What's the actual surface on the waterproof on top of
The TPO.
Right, membrane.
Yeah, so membrane, it's all welded up, so it's not like the old butanol, it's the newer version. So trying to think of anything else that's from a construction point of view.
Have you got services up there?
Services?
In the roof?
No, so that's a good point. So up on top there, as you can see, we had to map out everywhere where the lights were going well beforehand. So we had to pull the holes, so map it out on the floor, transition it up. So all the cables are up that are underneath the polystyrene, and then have been brought through and they've been all sealed with sealant as well. So basically in the areas where you see a jib plasterboard ceiling, actually something else I forgot to mention was the balanced ventilation system. So there's a balanced ventilation system throughout. You'll see the vents around the place. So there's two systems. There's some ducting coming through the concrete floor in the bedroom, and they go down to the unit downstairs. And then everywhere you see where there's a plasterboard ceiling, there's a 90mm surface cavity that allows us to keep the ventilation ducting within that thermal envelope and within the airtight layer, so there's no penetrations through that.
Dan, I've watched this build from the beginning. How long has it been?
Not sure actually, it'll be a couple of years. Yeah.
I lost track.
Yeah, no, it was quite a complex build, being on the hill, being, getting things to site, and the fact that it is quite, with all the different layers, it's not a conventional foundation, then framing, then roof, and then, so, yeah. But no, it was a very exciting build.
The foundation was phenomenal.
Yeah. We've got probably about 5 trucks of blue rock sitting out at home. Some of it's going to come back for some more landscaping, but failing that, I think we'll be building a garden at home, some sort of rockery. Yeah. So the other thing about which Bob will probably touch on when he talks with you is you'll notice obviously the large eaves. So we've used the CLT to create the eaves. So obviously when you can see here in the low sun in the winter, that the sun is coming in here. So the higher the sun in the summer, then obviously these longer eaves are going to shade. So it's not going to have minimizing that overheating. On the windows facing in the bedroom, and there's one downstairs in the lower room, there are electric roller blinds. Not so much for shading, which you can obviously utilise in your own house as another way of getting shading to stop overheating, is that it's more about privacy. Because of the thermally broken windows, you don't really need thermal curtains. It's more about people having a wee look.